Good morning. I want to thank the organizing committee for agreeing to present our work entitled Knowledge Processing using Bayesian Network in the Intelligent Tutoring System in the International Conference on Multimedia Computing and System. For that reason, we will present the outline below. First, we will present the smart tutoring system and their problems. After that, we present the background in the related works. Then, we will describe our proposed process, knowledge processing in the expert model. In the part 4, we will illustrate numerical results and the node evaluation. Finally, this presentation will conclude with a conclusion and future works. Passed now to the first part, that is introduction of the smart tutoring system. Intelligent Tutoring System is a system that provides feedback. In our proposed tutoring system, we integrate the implicit and explicit interventions into ITS. This tutor will select the appropriate strategy according to 3 criteria: data from learning progress, student model, and affective reacts. This modification is concerned the instructional model. This later have a bidirectional communication with the expert model. This model is the basis part in smart tutoring system. This module encounters a lot of problems, namely, first, lack of the importance of the taxonomy of the knowledge domain. Second, the expert model use just declarative knowledge. Third, enhance the learning evaluation. For that reason, we propose the solution below. This illustration presents the combination of applying, experiencing, and conceptualizing and analyzing knowledge processing. This knowledge processing contains 3 categories: declarative, procedural, and conditional knowledge. To enhance our contribution, a background research and related works is required. Concerning the expert model tools, the preview research uses generally 3 tools. The first one is the concept map. This later is an oriented acyclic graph that connects the concepts. The second one is the fuzzy cognitive map. Determines the correlations between the goals via a direct acyclic graph. The last one is the segmentation of the expert model. It means the pedagogical module saves the tutorial material on the problem generation module, generates an unlimited number of problems based on samples. To manage the knowledge processing, we propose to use the Bayesian network method because it's based on probability. In our case, it's a directed acyclic graph. And the type of relationship in our case is a diagnostic relationship because it's a direct from the target variable to evidence variables. Passed now to the proposed process, knowledge processing in the expert model. In e-learning platform, the learner needs a smart tutoring system to provide the feedback. This system contains 3 models. Our contribution is focused on the expert model. The aim of this work is to manage the knowledge in such way the 3 categories are combined. Each category may have an implicit status or explicit status. The figure below presents the different probability of knowledge. Knowledge may be a declarative, procedural, or conditional. Each of them is depend on status and type of activity. In this section, we will illustrate the implementation phase. This phase is subdivided on 3 parts. The first one is the construction of Bayesian network graph, who contains 1 parent and 3 child. Each of them depend on the category of activity and status. The figure below illustrates the probability of an activity to contain knowledge, conditional knowledge. We can see that in conditional knowledge, we should to have an expert activity, and this activity contains both status, implicit and explicit. To measure the performance of knowledge processing, we should use a lot of metrics. The first one is the global confusion matrix. Then we calculate the probability of correct classification. After that, we calculate the marginal probability of correct classification. We should have the marginal improvement. After that, the individual probability of correct classification and the cost rate. The illustration presents the node evaluation that is knowledge category as a target, and all the nodes are the evidence. So the probability of correct classification in our case is 57.98%. Finally, we arrive to the end of this presentation. In this presentation, we have presented the problem of the expert model in the smart tutoring system. We present the related works and we describe our proposed process. After that, we illustrate the simulation part of our contribution. The objective of the contribution is to propose a pedagogical solution which is based on the management of declarative, procedural, and conditional knowledge in the expert model of smart tutoring system. And as a future works, we aim to implement this solution into our FPL e-learning platform. Thank you for your attention that you make for my presentation.